Okay, class, welcome to lecture 8. Today we are talking about polynomials. So you've probably heard this fancy word before. Maybe it sounds very scary and confusing, but hopefully today won't seem so bad. Okay, so first of all, what the heck is one of these? Polynomial is, it's just a bunch of, I'm going to be very informal here, of powers of x multiplied by numbers and added together. So understanding polynomials is much easier when you just see examples. So we're going to jump straight into that. So this is an example of a polynomial. So I need powers of x multiplied by numbers. So something like this, 5x squared. So x is a variable, and x squared, of course, means that I'm multiplying x by itself. And then I can add more of these together. So for example, I could have a 3 times a different power of x. I don't know. How about that? And I can just have more and more of these. I can have subtraction. There's no need to only have positive numbers. So I could have 2x. Now I don't write the 1, but an x with no power just means an x to the 1 secretly. You never write this, but it's secretly there. So this is an example of a polynomial. And in fact, I can add something with 0 powers of x, which is just a number. So there's a secret 1 over there, but there's also a secret, if you just have a number, you do have a power of x next to it, multiplied by it. It's just 0 powers of x. So this is also a secret. You don't tell anybody, but it's there. You just don't write it. And it's because anything to the 0 power is just 1 anyway. So that just becomes negative 10 times 1, which is negative 10. So you would never write those secret things. So let me just rewrite it one more time. So you would just write it like this, and this is a polynomial. And what people like to do is say what degree they are of degree, and that just means the highest power in the expression. So what's the highest power that you see in here? An x to the 5th. So of degree 5. Okay, so that's one thing you can identify when you see a polynomial. And what else can we do? Well, for now, we'll just list a bunch of examples. So typically, we write them in order of highest power, just because it looks more aesthetically pleasing and keeps things organized better. So you would typically see something like this. So if 6 is the biggest power, then you would write it first. If x to the 4th was the next biggest power, you would write it next. Something like this. You would write it in this order because 6 is the biggest, then 4, then 2, and then 0 powers, aka just a number. So this is another example. And it's of degree 6, right? Because 6 is the biggest. It's a polynomial of degree 6. So there's also nothing that says that it has to be whole numbers. It's just that whole numbers are nicer. So we use them, but you could be very annoying. So you could say like 2/3 x to the 10th minus a half x squared plus 4. Is still counts as a polynomial. It's just like slightly more annoying. You could even have weirder numbers that you might not remember. Some numbers like pi, those count as numbers too. So you could put that there. But what you cannot make a bit weirder are the power numbers. These always have to be whole numbers. That's 0 can be the lowest, no negatives. So these are always positive or 0. and only whole numbers. So if you start putting fractions up there or negative numbers, you get something different. They don't count as polynomials. Okay. All right. So, but the front numbers that you're multiplying your powers of x by can be any number. It doesn't just have to be nice numbers. Okay. So what can we do with these things? So that's what a polynomial is. What can we do with these? Well, polynomials show up a lot in equations and formulas, in all sorts of sciences and things. But right now, these are just expressions. Notice these are not equations. There's no equal signs. I'm just writing down expressions. So what can I do with these expressions for now? Well, one thing we could do is we can just try to add and subtract them. Just to get a feel for how they work. When you see something new in math, you don't want to just jump to the end. You sort of want to dip your toe in and just barely try a couple things at a time. So let's just see how to add and subtract these things. So for example, if I have one polynomial, so this would be a degree 2 polynomial, how would I add it to another one? So this is another 2-degree polynomial. Degree 2 polynomial. How would I add these together? Well, we just combine like terms is the saying. And what that really means is this number in the front represents how many x squareds you have. So I have 7x squareds and I have 2x squareds. So since 7 plus 2 is 9, this gives me 9x squareds. So this equals, I'll just do one step at a time. I'll put the x squareds together. I will put the x's together with just one power of x. You don't have to do this as extra step here. And I'll put the numbers with no powers of x next to each other just to see. And this is how you add the two polynomials. So 7 plus 2 is 9. So this gives us 9x squareds. Another way to think about it is you could actually factor out the x squared here from the 7 and the 2. And so then you get 9x squared. Same idea, but you don't have to do it like that. It's a bit weird to do it like that. You could just combine 7 and 2. They have the same power of x, so they combine into 9x squared. Okay, then 5x minus 10x, because 5 minus 10 is negative 5. This is 5x, negative 5x. And negative 3 plus 9 is positive 6. So adding polynomials is just adding up the same terms. So they don't have to be the exact same degree or have a bunch of matching terms to be able to add. So let's see something a little bit stranger maybe. So negative 5x to the 4th minus 5x cubed plus 3x. And instead of adding, we will subtract the next polynomial. So 2x cubed plus 10x squared minus 7x plus 10 will be the other one. So adding was just combining like terms. Subtracting is also with one extra step. Because what we have to realize is that this subtraction is really going to every term here. So this is really saying, for example, what's 3x minus negative 7x? But you don't have to do it all in your head and try to keep track of the negatives. You can just distribute the negatives first. So that's what we're going to do. It makes our life a little bit simpler. So we're going to first distribute the negative before trying to do everything. So the first polynomial we haven't done anything to, so we're just going to keep it exactly the same, write it down very carefully. But the second polynomial, we've now distributed the negative. So that becomes a negative 2x cubed minus a 10x squared plus a 7x minus a 10. Because all the signs will switch when you multiply them by a negative. And now it just becomes like what we did, combine like terms, not everything has to have a like term. So for example, there are no other x to the fourths to add this to. So it's like adding it to 0, it just stays exactly the same. But now I look for things that are the same. There's a cube here and a cube here. A third power is another way to say it. And so I can add those two together to get negative 7x cubed, or x to the third. There's only one power of 2, so that is not going to get combined with anything. But then I have a 3x and a 7x to add up to 10x. And then I only have one number, minus 10. So that's the end of that one. Okay, so hopefully not too bad so far. It really just comes down to adding the numbers in front of the x's while keeping track of matching up the same powers. Okay, so that's how you add and subtract them. So later, we're gonna do a little bit more complicated stuff. We're gonna multiply and divide, which if you remember from growing up, first you learn adding and subtracting. It's okay when you're a kid, and then you learn to multiply and divide, and it's a little bit tougher. Same idea with polynomials. This will be a little bit tougher than adding. But first, we're going to use polynomials as functions. We're not going to really do anything with them yet. So we can use polynomials to make functions, because remember when we had functions, what we would do is we would say the function is called f, and then we would write f of x equals, and then on the right would be a bunch of stuff with x in it, and that would tell you what the function was doing. So now we could use polynomials on the right to make functions. So for example, you could create a function that is a polynomial by just writing it. Let f of x equals 2x squared plus 10x minus 1. So now we have a polynomial on the right defining a function. So then you could do function stuff, for example, f of 0. So we sort of already did this without saying it before. So this would be 2 times 0 squared plus 10 times 0 minus 1. 0 plus 0 minus 1 equals minus 1. So, but I think we always kept it at most power of 2, but now we have fancier polynomials, so you could do fancier things if you want. We already know how to do function stuff like that, so we're not going to worry too much about that right now. But then when you create functions, you create all sorts of questions that we learned about when we learned about functions. So then you could figure out, like, you could ask this, like these types of questions, like how do I graph these? How do we graph? Because when you have a function, you can try to make a graph of it. So how do we graph polynomials? And then that leads to all sorts of tools to help you do that. And so that's what eventually we'll do later. But that's like the main question that we can ask now. How do we graph these types of things? Okay, but that's not where we're going yet. For now, we want to connect this back to what we just did, which was adding and subtracting. So we can, this is not an example yet, sorry. We can add and subtract functions, which we haven't done before, in the following way. And then we can practice doing it with polynomials. So the idea is that if you have two functions, so I guess I'll just reuse the one I created just now, and then I'll get another one. So if you have two functions, how would I add them together? What would make sense to do? Well, I guess it would just make sense to add the right sides together. If you wanted to add two functions together, that's the most logical thing to do. And it's exactly what we are going to do. So then we can create a new function And so notation wise, it'll be called f plus g. So people get a bit confused by this. And how would it be defined? Well, that means figuring out what is f plus g of x. And it's just adding the two functions together is defined by adding these two things together. So we'll just do the example and it'll be a little bit less confusing. Okay, so here in our example, let's just do it. F plus g of x is supposed to equal what happens if you have f of x plus g of x. And so all I'm going to do is put these guys in there. So this is f of x. This is g of x. So I'm just going to put them in there. And then we know how to add polynomials. So we'll know how to add these two together and simplify it. So that's what we'll do. So now we can add these together since we just learned how. So 8 plus 2 gives me 10x squared. 10x minus 1x gives me 9x's. And minus 1 plus 4 gives me plus 3. So this is what the new function we created called f plus g is. So what you should do is you should think about this left side. This is sort of like a name of the function. And then this is like how you create the function. And then this is what it is at the end when you get it after you simplify. Okay, so we'll do another example. Very similar. You could probably guess. Now create, what do you think this would be? F minus g of x. Well, it must work exactly the same. It's just f of x minus g of x. And that's exactly what it is. So all we're going to do is substitute in f and g again. Luckily, I just rewrote them. So let's do that. So this will be 2x squared plus 10x minus 1 minus g of x, 8x squared minus x plus 4. So now we're subtracting two polynomials, and so we just do what we did that time, which is first distribute the negative before trying to continue. You could do it all at once if you're very comfortable, but I wouldn't recommend it. Minus 8x squared. You distribute the negative to the first one. This becomes a plus x on the second one, and a minus 4 on the third one. Now I will combine like terms. 2 minus 8 gives me negative 6 of the x squareds. 10 plus 1 gives me 11 x's, and minus 1 minus 4 gives me minus 5. So this is what f minus g of x is. And we calculate it using this formula, which is just subtracting the two polynomials. And then again, this is just the name of what we've created. Okay, so let's do one more example just for emphasis. But if you've got it by now, you probably don't even need this last example, but I'll just do it one more time. So let's calculate f plus g of x and f minus g of x for, so I'll just give you two functions here, x cubed plus 4x squared minus 5x minus 4. And g of x will just be 4x squared minus 7x minus 1. So again, they don't have to match in terms of degree. The first one is degree 3. The second one is degree 2. You could still do this. Okay, so then what do we get? F plus g of x will be just adding the two polynomials together. So I'm just going to do that. X cubed plus 4x squared minus 5x minus 4 plus, notice I don't really need this parentheses when I'm doing the addition, but I'll do it one more time. But when you're adding a bunch of stuff together, it doesn't matter if you parenthesize. or not. It'll be the same result. So in any case, let's see. So there are no other x cubes this time. So when I add x cubed to nothing, it'll just stay the same. There are 4x squareds here and 4x squareds over here. So that'll give me 8x squared. A minus 5x and a minus 7x will give me minus 12x. And a minus 4 and a minus 1 will give me minus 5. So that's f plus g of x. And then f minus g of x is going to be just doing very similar things, subtracting this time. So when you subtract, parentheses do matter. They are very important on subtraction because if you don't have the parentheses, then your negative will only be attached to the first term, which creates a completely different problem. So just real quick, notice if I don't have this parentheses here, so this is wrong, do not do this, then it's completely different than if I do have the parentheses there, because now the negative not only goes to the 4, it also goes to the -7 and the -1, which changes things completely. Okay, so now we can continue. So we're just going to distribute that negative through. And that will become a -4x squared, positive 7x, and a positive 1. Now I can combine like terms. Again, there's only one x cubed term, so it's not going to change at all. These will actually cancel because I have a positive 4x squared and a minus 4x squared. So what I have not been doing is writing zeros, but you could do that. So whenever I was missing a term, so I'll scroll up after and show you, I wasn't writing that there were none, but you could do that. So I'll write it for now. In any case, minus 5x plus 7x gives you plus 2x, and a minus 1 and a plus 1 give you 0. So what's going on is if you have 0 of something, you just don't write it typically. So you would then simplify this a little bit by just writing it as x cubed plus 2x. So people just don't like to write that there's nothing for some reason. So we leave these out because there's 0 of them. And I've secretly been doing that in other examples. So let's see if I can find a nice one where I did that. Just to show you. No, not there. I have all of them there. Oh, right here. So for example, this one had no numbers in it, but I didn't write plus 0, even though I could have. It's just unnecessary. I think I must have another. And then on these ones, similarly, it would be super annoying if I wanted to write all of them. So if just because I have a 10 there, I'm not going to write 0x to the 9, 0x to the 8, but they're all there. They're just all zeros. You just don't want to write a bunch of zeros because it's just a waste of time. Okay. In any case, that is the end of the lecture today. So I will see you next time.